In this video, we're going to go over pendulum problem, but a very specific type of pendulum problem where you are given a graph of data and you have to find out something about the pendulum, right? This is a very applicable example because not only can you be given different problems, right, to solve on your quizzes and tests that are related to this concept. But also, this video will be very useful for those of you who have physics labs, right? Because I will teach you how to analyze basically information and graphs that you guys make in your lab classes. So let's take a look at our problem. Here, don't be scared by the amount of these words. So here in this physics experiment that takes place on a different planet, we have a string tied to an end of an object of mass m, essentially a pendulum, right? And the other end is fixed, allowing the object to hang vertically at rest. The object is then lifted to a certain height above its lowest point and then released, causing it to swing back and forth in simple harmonic motion. Again, this is just an explanation, right, for a very normal, very generic pendulum. The data collected from this experiment are graphed in a manner that linearizes the relationship involved, right? Linearizing just means that they created a line, right? They wanted the final graph to look like a line. The question is the following. So what information from the graph can be used to determine the acceleration due to gravity g? And for an object that is released from rest near the planet's surface and allowed to fall freely from the ground. So what info basically we'll ask, how can we find g, right? And also what g is. What is the acceleration due to gravity on this planet? So let's take a look at this graph. Okay, so here we have a graph of period squared in the units of seconds squared versus length of the string, right? In the units of meters, right? Sorry for my cursor. So these bunch of dots represent basically the scatter plot, right? So our let's say is anyone who takes measurement never are our measurements so precise, so therefore they're going to be deviate a little bit. But as you can see, the best fit line, right, is a line that goes like this. So as with all the questions before, right, we're going to start by writing our equation for the pendulum. And the pendulum, the equation is the period of the pendulum is 2 pi square root of L over G. Now, here's what I want you guys to think about. In majority of the labs, right, I would say 90% of the labs, when you graph your data, you either look at area or slope. Most likely it's the slope. So something we can get from this graph is the slope. So the slope is change of y over change of x. So it's the period squared, t squared, over L, right? Now the question is the following. This is the information that you have, right? And we can calculate the slope, right? Let's take some of this value. So for example, the rise over run, right? It's 6. T squared is 6 over 3. So the slope is actually 2, and the units will be seconds squared per meter squared per meter. Now the question is really, we know the situation has to do with pendulum, right? So hence that's why I wrote the pendulum equation. So how can t squared over L be related to the pendulum equation, right? It might not be exactly clear how, but what you do have to do is rearrange this equation, right? So that you just have t squared over L on one side and the rest of the quantities on the other side. So let's take this equation and rearrange it. First, I will have to basically divide both sides by 2 pi, and I have square root of L over G because I need to take L out from the square root. Then I will square both sides. So on the right hand side, my square root will cancel out. So I will have this. On the left hand side, I will have to square each quantity, t squared over 4 times pi squared. As you see, this unit is really more so about, at least the pendulum part, is more so about you knowing how to rearrange this equation. So once you've practiced a few problems of rearranging the pendulum formula, you should feel pretty confident, hopefully, about most of these problems. Okay, let me keep going. So again, we're trying to get t squared over L as our final as a left hand side. So let me cross multiply those. This times this is equal to this times this. So t squared times g is equal to 4 pi, is equal to 4 pi squared times L, okay? Now, I want to divide both sides by L and then divide both sides by G. So just like this, I have finally found what my slope is. So my slope is equal to t squared over L, and I can use it to find 4 pi. So if you remember, my slope was this, right? So since my slope is equal to t squared over L, I can simply plug this in here, and I can rearrange this equation now for G, right? Because that's what I'm actually trying to find. So let me multiply by G on both sides and divide by M on both sides. Okay? So 4 pi squared over M, which is, my M was 2, the slope of this graph, so 2. So it's going to be 2 pi squared, or the final answer is 19.7 meters per second squared. That's going to be the gravitational acceleration on this planet. So what are some things that we can take out from this problem? So the first thing, if you have some sort of experiment, right, and you're given some sort of graph, what I want you to think about right away is the slope. So first you write out what the slope would be equal from this graph. Then I want you to think about what equation would apply to this lab or this experiment, right, that you're thinking about this. In this case, it was the equation for the pendulum. And then I want you to think, okay, how can I rewrite this equation in terms of this slope, right? Okay, so just like this, we looked over this example. Now, in the next videos, we're going to keep working on simple harmonic motion. And so keep watching these videos and keep practicing these problems on your way to an A. Thank you guys for watching.